Hi, I'm Chris Muchler, VCDX 257 from virtualelephant.com, and welcome to my Networking Fundamentals online training course. In this module, Module 1, we are going to discuss the OSI model. Let's get started. Module 1, the OSI model. The OSI networking model was originally developed as a conceptual framework to standardize and describe the functions and interactions of various networking protocols. It came into existence in the 1970s when different hardware vendors were each introducing their own proprietary networking systems, and the industry saw a need to standardize the networking protocols. Officially released as ISO 7498 in 1984, the OSI model has become the default model for all modern networking technologies. After its official publication in 1984, the OSI model became the standardization for all modern networking technologies that exist today. While its practical implementation has become rather limited, it is still used as an educational tool for all new networking administrators and networking engineers to be able to provide a solid foundational understanding of the different layers that exist across a networking stack. The OSI model introduced 7 different layers, which we are going to cover in detail in this module. It's important to remember that while the OSI model didn't become the basis for the internet, it has played a significant role in shaping the field of networking and continues to be used for educational and reference purposes. As we dive into the different layers that make up the OSI model, you can see here on the screen on the right side all 7 layers. Now L1, starting at the bottom, is the physical layer all the way up to L7, the application layer at the top of the graphic. Now each layer is going to define a typical set of network functions, and these are going to be used as reference points as we discuss the different protocols that exist in a networking stack today. It's important as we look at the 7 different layers that we notice that the top 3 layers, L5, L6, and L7, are focused primarily on the applications, while the bottom 4 layers, L1 through L4, are focused on the end-to-end delivery of data. It's important to remember that as we're discussing the OSI networking model today, these 7 layers are commonly used as a reference point in all discussions around networking, even today. And although the OSI model has not seen a practical implementation, it is still the reference point from an educational standpoint for all conversations around networking even today. When you hear a network engineer refer to something as L7 or L4 or L1, they are referring back to this, the OSI model. And even though we see that the TCP IP model, which we're going to discuss further in Module 2, is an actual practical implementation of a networking standard, it is based, again, on this OSI model. So the OSI model really does form a key foundational topic for each of us to understand as we're trying to learn more about networking in the data centers. Now, as we dive into the top 3 layers, L5, L6, and L7, we're going to start with L7, which is the application layer. Now, this is going to define the interface between communications of different software points. Think of things like a web browser and how they communicate between a web server and the browser that you have open on your laptop or desktop. Some of the common protocols that operate at the L7 OSI model are things like FTP, HTTP, SMTP, NFS, and others. Moving down to layer 6, the presentation layer, this is where data formats are going to be defined. Things such as ASCII, binary, and JPEG. Now, it's also important to understand that the presentation layer is where encryption is defined as a presentation layer service. So this means that we're going to see things like SSL and TLS for secure data transmissions, as well as JPEG formats for images themselves. Compression is also going to take place at the presentation layer in the OSI model. Layer 5 is the session layer, and this is really where we're going to start to see things being defined around how a session is started, stopped, and controlled in the middle. Think of an L5 session as a conversation between two different devices on the network. So here we're going to set up controls around those bidirectional messages so that applications can send notifications between endpoints to understand if those messages were received or if there were errors and they were dropped. Some of the common protocols that operate at the session layer include things like RPC, NetBIOS, and SMB. It's also important to remember that things like SQL queries actually take place at the L5 session layer. As we move into the bottom 4 layers of the OSI model, we're going to start here with L4, which is the transport layer. Now, the transport layer is going to be focused on issues related to data delivery to other systems on the network. So things on how to handle error recovery, segmentation of large application data blocks, and breaking those data blocks up into smaller chunks that can be transmitted over the wire and then reassembled at the destination. The transport layer also handles things like flow control and using sliding windows and acknowledgements, which we'll talk about more when we get into TCP IP. Now, some of the common protocols that take place here are really the core two that we're most familiar with, TCP and UDP. Moving down into layer 3, this is the network layer. So when we think about how networking got started and we first initially started sending messages across the network and determining how a message could go from point A to point B to point C, this is where routing came into play. Routing in and of itself has been defined at the network layer in the OSI model. So when you hear things referred to as an L3 routing device, this is what they're referring back to. And so routing and the network layer really takes care of the end-to-end delivery of the packets. It's also where logical addressing is going to be used to identify the different endpoints. Think of an IP address here. In addition to that, this layer is going to determine how routes are learned and then how routes are delivered across the network, determining best paths. Now, common protocols at this layer are IP, ICMP, and OSPF. Now, layer 2 is the data link layer, and this is where we're going to find the definitions for frame sequencing and MAC addressing. Now, a MAC address is the hardware address of a device, much like an IP is the logical address assigned to a virtual machine or a computer on the network. A MAC address is assigned to the physical device that is connecting itself to the network. So this can be a physical device like a NIC in your laptop, a Wi-Fi controller in your laptop, or it could be a virtual NIC inside of a virtual machine that's either running on-prem in like a vSphere environment, or a virtual NIC that is running inside a public cloud provider's virtual machine. Now, there are two common standards that you should be familiar with when we talk about the data link layer, and those are the IEEE 802.3 and the 802.2 standards. And these standards define the common protocols, including Ethernet and then high-level data link control, or HDLC. And this is what we're going to really try to understand more as we start talking about how packets work and they start getting handed off from one layer to the next. Now, the final layer inside the OSI model is layer 1, or the physical layer. And this layer is going to define the physical characteristics of the transmission medium itself. So think about things like connectors, pins, electrical currents, and light modularization as all different parts of the physical layer specification. Now, most of these specifications also find themselves defined in that same IEEE 802.3 document. And one of the most common form factors that you're probably aware of is the RJ45 form factor for connecting a NIC to a physical switch, a cable modem, a DSL router, whatever you might have in your home. Now, as we conclude this module on the OSI model, one of the things that I want to share with you and demonstrate to you is how the OSI model has been leveraged in the practical application of the TCP IP model, which we're going to get into more detail in Module 2. So this first graphic that you see appearing on the screen is the OSI model that we just reviewed. You can see all 7 layers here defined as we discussed. And then as we compare that to what the TCP IP model looks like, you can see that they condensed it from 7 layers down to 4. But then as you look at them side by side, you can see that the OSI models L2 and L3 have been combined into a singular network interface layer in the TCP IP model. Now, the network and the internetwork model layers between the two models are essentially the same, as well as the transport layer. The key difference here are the top 3 layers in the OSI model have been consolidated down into a single layer called the application layer in the TCP IP model. The final graphic that I want to share with you is an alignment between the TCP IP model itself and the protocols that operate at the TCP IP layers. So you can see that the bottom network interface layer in the TCP model is where you're going to find things like Ethernet, frame relay, and TCP. And then the internet layer of the TCP IP model corresponds to the IP protocol. And then TCP and UDP find themselves at the transport layer, while things like HTTP, SMTP, POP3, NFS, and a myriad of other application layers find themselves aligned with the application layer within the TCP IP model. So this concludes Module 1, the OSI model. The thing that I want to make sure that you take away from this is that you need to have an understanding, and even to a certain extent memorize, what the 7 layers are that make up the OSI model. Because as you have conversations with colleagues, network engineers, network architects, and what have you, they are going to commonly refer to things as L1, L2, L4, L5, L7, and those references come back to this OSI model. When I was learning these network fundamentals in the mid-1990s, I actually had to memorize the OSI model itself and understand what each one of those individual layers encapsulated and included. And I think that that memorization and that focus on the OSI model in almost every networking engineering class that I took at the university really helped give me that solid foundation, which is why I wanted to make sure that we covered it here in this online training class. If you like this training course, please make sure that you subscribe to the YouTube channel and leave a comment below and let me know what you think. I look forward to seeing you in Module 2.